Hello. So today we will be solving the question that came from recent weekly contest, that is 4 to 9. And the question is 3397. That is maximum number of distinct elements after operations. Okay. So let's first understand the question. You are given an integer array nums and an integer k. You are allowed to perform the following operation on each element of the array at most once. Okay, means in each element you can apply this operation at most once. Okay, so the operation is that you can add an integer in the range minus k to k to the element. Okay, now what you need to give the answer is that the maximum possible number of distinct elements in the nums after performing the operations. Okay, so let's first understand the equation with the help of the example. Okay, so let's take this example. Okay, so this is our example, and what is the example is telling is that, okay, so this is one. Okay, now see here, what happened is that you can add to this one from the any element, that is minus 1 0 1 0 and 2. Okay, so you can add any element from this. Okay, so 1 you add minus 2 to make it minus 1, you add minus 2 here to make 0, you add minus 1 to make 1. Okay, you add minus 1 to 3 to make 2, you add 0 to make 3, and okay, and the same way you add nothing to be at 4. Okay, so all the elements are distinct, and so our answer is what? It is 3. Yes. The second example here is about 4 4 4. Okay, so what we did is that, okay, so let's take it there. So what we did is that we add minus 1 to here to make it 3. Okay, we add minus 0 means 0 to get 2 before, we add plus 1 to make it 5, and this 4 was as it is because that is we can't do anything for that. So its answer is number of distinct elements, that is 3. Okay, now let's understand with some example, okay, what our approach will be like. Okay, so here see, let's say we have this array 1 1 1 1 1 2 2 2. Now before any operation we have only 2 distinct elements, but now see, we have been said that you can apply at most one times. Okay, so why not to apply the operation at each of the elements? Okay, because it is minus k to k minus k to k. If we do not apply to the operation, means adding 0, that is same as to apply the operation. Adding 0 is the same thing to apply the operation. Okay, so my main aim is that to apply the operation. Why I am saying that? Because see, my main aim is to shift this one to go leftmost side, so that I can accommodate between elements also. What I mean is that, see, we have option to make this one what the smallest possible. So I can make it, I can add a minus 3 to it to make minus 2. Now see, there is directly a 1. Okay, there is directly a 1, right? And still minus 1 0, these are the two other elements which can be accommodated and which can be formed. So that's why my main aim is to make the elements go leftmost side, so that I can get more distinct elements. Right, now see this second one. This second one will be made minus 2 to make what? This minus 1. This one would be made to what? Minus 1, will be added minus 1 to get 0. Now this one will be added 0 to get 1. Means we are trying to, okay, what left side, what is the leftmost element I can make, because so that I can pack all the elements. Right, here in the same way, here one, what we add plus 1 to make it 2. Do not worry about the 2 here, it will automatically take care. But this left side, the main aim to go for to pack up the left side is that so that we can use that range. We can use that range. Understand? We can use that range. Okay, to make to maximize this range of or the number of distinct elements. Okay, 1 and 2, and okay, so this one was made 2. Now this 2 was made what? Please tell. +1, that is 3. Yes, my friend. Now this 2 was made what? Please see. Yes, +2, that is 4. This 2 is made what? This 2 is made 5. Yes, good. So this is how we will form the number of distinct elements, and here our answer for this case k = 3 and this array of 5 1s and 3 2s, it will be 8, right? Let's say what if we were also having here 1 2 2 2 and 3. Let's say we have 2 2 3 more. Now what is our algo? Okay, make this 2 leftmost side what we can make. Okay, here. Okay, so here, oh wait a minute, here this 2 what we can make what? We can make 5, right? We can make 5. What leftmost I can make from this 2? I would check from the set. Okay, so I would be using a set data structure to store this elements, and I would check here, use find function, s.find function, set.find function to check what leftmost I can make. Here also 2 I can make 5. I would insert it. Here 3, what is the leftmost I can put? Say that 6. Okay, so for this our answer is like, okay, 3 plus 5 8 and 8 plus 1 9. So our answer will be 9. Okay, now you will think about, okay, so for each how would I check? Because for this, let's say for this 3, I would be checking from -3 to 3, means 3 minus 3 I will check 0, then -2 I will check 1, I will check 2, I will check 3, I will check 4, I will check 5, means 3 plus 2, then 3 plus 3, and after this point I will find, okay, so this is means this 2k times, it is 2k times 2k into the number of elements of the set. In the worst case it is log. Okay, so 2k as its time complex, it is logarithm, so it is 2k into log n, right? It is log n, right? So it is log n. Okay, it's log n, right? So 2k into log n is our time complexity, and we have to do it for every element, so it will be into n, right? Into n. Now k's range is from 1 in 9, so it will give TLE. It will give TLE. Can you think about, as this 2k is it is a linear search, can we make it a binary search? Means in searching for this, okay, so let's come to the point. Let's say we search for the first thing, as we have -3 to 3, right? -3 to 3 means we have to search for -3 plus 3 to 3 plus 3, 3 plus 3, right? 3 plus 3. Now that is 0 to 6 we have to search. Let's say this is low and this is high. Okay, let's say we search for first 3. Now we find it, okay, using s.find function, we find that 3 is already there. See, we are here only, we are checking for the last element. It can be generalized to any element. If we checked it, okay, 3, the element 3 is already present. And as we know, I know for sure that okay, we have packed up all our left elements. Means it's obvious that there will be 2, there will be 1, there will be 0. If 3 is not satisfied, we surely know that 2 and 1 will be there. So we will negate this range, and then we will check for further here. Our range will be now 4 to 6, and now we will check for 5, but 5 is also there. We will negate this range, 5 to check for 4, then check for 5 and 6, 5 and 6. So okay, so 5 is not there, so now the range is what, 6 to 6. Yes, 6 is not there, go for it, and our whole range is completed. So this is how we will be using binary search. And so now this k would be converted into what? This 2k, or I would say 2k would be transformed into logarithmic of 2k. Logarithmic of 2k into log n for s dot find function. Okay, and okay, so log n, okay, into n. This is our time complexity. Okay, so if I would write it in the new page, so our final time complexity will be log into 2k into what? This is log 2k is our search space, okay, into log n. It is because of set s dot find and n, okay, for each element. So this is our final time complexity. Let's get to the code and submit our solution. Okay, so first decide our range. Okay, so for each element we would do here. Okay, now what is our, okay, so as nums of I can be 1 in 9. Yes, let's go for using long. Okay, so I would define here, it's always a best practice to write this so that your code becomes faster to write. Okay, so ll low, what is low? it minus k. ll high, that is what? it plus k. Our whole range, okay, whole range. Let's maintain a set here of number of distinct elements. Okay, and our answer will be what? Return s dot size. It is our number of distinct elements. Okay, now let's go for search space. You should be knowing that our main aim is what? Main aim is to pack left side. Okay, so okay, so while low is less than or equal to high. Okay, this is a general binary search code. Okay, what is our mid? Mid is low plus high minus low by 2, right? By 2 mid. Now what if s dot find mid is not equal to s dot end? Means it is present. If this element is present, means its left side will also be present. If in this case I show you, okay, that if already our 3 is present, that is our mid, why to check for this elements? So what we do, we increase our low to mid plus 1, low to mid plus 1. Else if it's not present, what I do is that I store it. Okay, so ll, the element that is to be inserted, I store it. Okay, I store it. So initially it is nothing. Okay, but here what I do is s dot find low equal to mid plus 1, right? Now what I would do is that I would store it my le mid, means this is the element that can be my leftmost element. Further I would check for more left side element. means here in the first in the in if you would say here in the first case, if minus 2 we would be checking from minus 2 to 4, right, to 4. Now in if we add it, so we get 1. Okay, so means minus 2 plus 4 by 2. Okay, so is 1 present? Okay, so as initially set as empty, okay, 1 is not present, so this can be my answer, but it's not sure that this is our answer. So it would be further changed by negating this whole half and now checking for minus 2 to 0 range. Okay, so this is what here we are doing. Okay, and finally, okay, so that's equal to minus 118. Why I am making it because to check, okay, if there may be the case that no means always the in the whole range we do not find any possibility. So to negate this, to not insert it, we would check it. Okay, so afterwards we check, okay, if LE is not equal to what, minus 118. Okay, means we have one element that is possible, our leftmost element. Okay, so I would insert it in my set, right? So this is the short code. Let's run it and see if it passes our answer. Yes, it's passing. Let's submit it and check. Okay, so it's giving wrong answer by minus 118. It's not equal to minus 118. Wait a minute. Okay, so it's my fault. Okay, wait a minute, there is somewhat issue. I need to sort my nums. Okay, I forgot to tell, it's for a sorted array. Okay, it's better to sort the array, right? Because we are packing all the left things, right? All the left things. So it's better to go for sorted. Yes, it passes all the test cases. Okay, so if you have any doubts, you can ask in the comment section. Thank you.